I need blue. There it is. Just amusing myself here first thing in the morning. Okay, I got 5 points. I got good morning. All right. So I got Brooks, I got Lisa, and I got Coco. So today's the 9/2/21 live. Brooks, Lisa, Coco. Who else I got? Okay, I got Stephanie. I got Frederica. All righty. Nice. Let's see who else I got here. So Frederica, Stephanie, Coco, Lisa, Brooks, and hope everybody's well. Hope everybody's staying sane, getting out there and playing in the snow. I've been out there with cross-country skis. Feels pretty good. Emelina, good morning. Swelleroonie. I don't understand your comment, Coco. Okay. Emil, good morning. Very good. Okay, let's see if we get a few others showing up, and then we can start up today with a little chemistry here in the morning on our snowy February day. Padum, padum. Hope everybody had a good week off. Enjoyed the snow and pre-snow. And there's Tully. Good morning, Tully. Had a little time to read, play, call friends and stuff. UCN, good morning. And Aaron and Julius and Jonathan, good morning. Everybody's flying in now. Okay, good. I think I got everybody. Yes, yes, yes. Still looking for Tilly and Remy, Mick, Marino, Jordan, Keanu, Yo, David, and Matthew. If any of you are there, Marino's there and David is there. Good. And yes, good. I got you, David. And Marino, I got you. Super. Thank you for showing up so early. Glad everybody's here. Guess it's not that early. Third period's not too bad. You probably already had another live stream by now. Okay, one more check and then we'll start up. So Tilly, Remy, Mick, I need, Jordan, Keanu, and Yo and Matthew. Any of you there? Keanu's there. Thank you for checking in. All right, and I will put that aside. And let's go ahead and begin. Okay, when last I saw you, and I couldn't even see you the last week because we had meetings and stuff before our winter break. Last time I saw you, we did what was called the Hoffman apparatus. And recall with the Hoffman apparatus, remember that thing? Okay, so we had these two two levels here, and the rest, we don't really care about that much right now. But the two levels, we had one that was full of gas and the other one that was half as full. And remember, we had gas here and gas here. What gas was the greater amount? Which gas was here? Which one had the greater volume? Which gas had the greater volume from this machine, the Hoffman apparatus? By the way, this was filled with water, H2O. So which gas had the greater amount? See if you remember. Go ahead and type in. And I'll label them once you give me some ideas, hopefully that are correct. Lisa, thank you very much. So hydrogen gas. So this side with the bigger amount was hydrogen. Okay, and somebody else about the other gas. So Stephanie knew that too, as did UCN. What about the other side? Which was there less of over on the other side? I'll use green for that side. Which was over on this side? So which gas had a lower volume? Which gas had a lower volume? You got it. Thank you, Lisa, Marino, Brooks, and others. So this was oxygen gas over here. But you know what? If you remember, I said, don't take my word for it. We're going to do a test. So I want to write the reactions today for those tests because we ran out of time. I said we would do it, and we didn't get to it until now. So we're going to write the word reactions. For two things. One, the hydrogen gas test. In German, Knallgasprobe. Knallgasprobe. Okay? Okay, so let's do it. By words, I mean we're not going to use the chemical formulas. We're just going to use the words. So we're going to start out with this and say, okay, I have hydrogen gas. Plus, okay, now I got to do a little, I can't do it here, so I got to remind you. Okay, what I did is I took a test tube. Let's pretend that's my test tube. And I let go of the gas. I opened up a valve here, and I got the hydrogen gas into my test tube. Remember that? And then I took it, and I lit it with a match. Poof. Okay, it went poof. Okay, so that's the canal. Okay, Knallgasprobe. So let's figure out what happened. Okay, I got a couple that are late, but here. So I got, I'm guessing that is, I got a Beargold, so I'm guessing that is Tilly. So Tilly, that's you, right? Yeah, it is. It's Tilly. Okay, so anybody else coming in late, say hello to get your points. Otherwise, I don't know that you're there. Okay, so when I lit that, when I took that test tube and lit it, I joined the hydrogen gas with what? With what? Hint, something from the air. So hydrogen gas, it joined with something from the air. Yeah, true. The match like started it, but what I mean, Brooks, is what other chemical? And I don't know if we talked about this, so you're going to have to be really thinking. I'm sorry I can't do it again here. So I opened it, so I had it here, then I opened up my finger and let not only the match in, but another chemical got in. Yes, UCN's got it. It's the oxygen gas. You might say oxygen gas. No, you did that separate. No, but this was oxygen gas from the air. Remember, you breathe this stuff, right? And when I made the Knallgasprobe, boop, those two got together and made something. and we saw little bits of it on the inside edge of the. Yeah, most of you got it. Oxygen. No, nitrogen doesn't do anything. Nitrogen's very unreactive, so not nitrogen. Oxygen. Okay, so once we lit it, what was made? Yeah, like the video, exactly. What was made on the inside of the test tube? One person has it. So what did these form? I had little tiny bits of something that formed in the test tube. Thank you, Coco and others. Water is right. And when it forms, if it's dry like winter, it can form mainly just gas. But if it forms when it's a really humid day, you'll see it as droplets. So I'll say water as gas. Let's not say gas, let's say vapor, because that's really more visual. So you can imagine the vapor. So as vapor or droplets. And at the same time, we had a poof, poof. Now, poof is not a chemical, but I want you to know that it kind of happens on the product side. So we put them together. We had a match to start it, as Brooks said, and then we had the water vapor and poof. And we also got heat given off. Now, you couldn't feel it, but the test tube got warm. So plus heat. So water plus heat would be our products for the Knallgasprobe, for the hydrogen gas test. Good. Let's do one now and if you got questions, please ask me. Just seeing if anybody else showed up. No, they did not. Okay, let's continue. So the second one we did was the oxygen gas test. Which was called, in English, the burning splint test. Burning splint. A splint is like a splinter, a little bit of wood. Burning splint test. And for that one, I can remind you by drawing a little bit here. I opened up the valve and I had a glowing piece of wood. And when I opened it up, it glowed even more. So I'll put some little dashes there, okay? All right, so that was the test for oxygen gas. So essentially what I want you to know is we had what? As an equation, we had oxygen gas plus, well, what's the splint made out of? What's the chemical basically? What was burning during the oxygen gas test? So oxygen gas plus what? Thank you, Brooks. You're awake today. That's great. Yeah, wood. Now, I'm going to tell you what formed because you'll have this in ninth grade, but it's kind of hard to guess in eighth grade. And we didn't test the products, okay? So it's hard for me to know. Thank you. Everybody got that. Stephanie, Marino, Coco, everybody's right. Wood. So what you formed was water vapor, even though we couldn't see it because it was a vapor. And when you burn wood, you also get something that's not very nice for the atmosphere. What else do you get when you burn wood or coal or gasoline? What other chemical? It's not so great for the environment. Well, what's in the smoke, Brooks? So water vapor plus, can you guess what other chemical? Not very good for the environment. Coco has it, as does Lisa, as does Emelina. So CO2, and we're going to call it carbon dioxide is the name for it. All right. Good. Yeah, well done. So those are the word reactions. Let's do the actual symbol reactions. I'm going to erase the picture of the Hoffman apparatus and just do with you the symbol reactions. So let's do the same order. So 1. Okay, let's see if you guys know. Okay, so type in hydrogen gas, what's the formula? And oxygen gas, what's the formula? So what are my two reactants here? Plus Can you type in what are my two reactants if I write them as chemicals? Yeah, kinda. Can I give you a hint? Brinkelhoff. Brinkelhoff. I need my two chemicals, oxygen gas and hydrogen gas. My hint is Brinkelhoff. So what's the formula for hydrogen gas? What's the formula for oxygen gas? All right, good, nice. Okay, we got it. We're getting closer. Okay, Yo is here. Yo, you'll have to watch the rest on video, but I will mark you down even though you're late. Okay, so Yo. Okay. Yeah, Julius, that's right. So it's H2 gas, G for gas, plus O2 gas forms water. So H2O. But you all know that. And I'm going to say gas because when we saw it was mainly a gas, just a few little droplets, mainly just vapor. Okay, vapor. Okay, now, my people, this is not balanced. Not balanced. Here's what I mean. Notice how I got two H's and one O. Here I got two H's and two O's. How could we balance this? Yeah, right, Stephanie? That's what I got. And it's not balanced. We haven't done this before. Could you help me balance it? Think of like a math thing. I got to have the same number of H's and O's on each side. How do I do that? Let's see some ideas. There's more than one answer. H2 plus O2 makes H2O. Yeah, but I got one O here and I got two O's here. What can I do to solve that? How could I solve that? What do you think? Okay, now Marino says I could change this to H2O, but I can't, Marino, because then it would be water. I can't change the little formulas for the chemicals because they are what they are. H2 is H2, it's not H2O. H2O is the product, that's the water vapor. Add another oxygen molecule. Good. Okay, Brooks, you're right. All right, so here we go. Wait a minute. No, actually, no, that won't work. I already got too much oxygen. If I add more O2s, then I got even more. I don't want more of those. I already got two of those and one of those. Other ideas. Marino says H2O plus O. Plus O. No, it's a good idea. I understand he's saying you could add an O over here. Yes, you could do that, but that's not what really happens. Add hydrogen molecules. Yes. Let's see why that's going to work, what Emelina said. Okay, check this out. What if I have not one of these H2s, but two of them? Put a 2 in front. Like if I had a recipe, I could have like 2 cups of flour. What if I have 2 H2s? Well, then I would have to make how many H2Os on the other side with that? If I have 2 H2s, I'd have to make how many H2Os? And Marino, nice idea, but I can't change the formula. It's not H2O2. That's hydrogen peroxide. It's H2O. It's water. So Emmeline is right. We're going to have now, instead of one, we're going to have 2 H2s. And Brooks says 2, and he's right. So let's put a 2 here. I know this is new for all of you. It's the first time we've done this. It's called balancing a reaction. Let's think about it. You ready? All right. It's a bit mathy, so put on your math cap. Here we go. I got 2 H2s. It's like a multiplier. How many H's do I got? 2 times 2 is 4. I got 4 H's. And I got, of course, 2 O's, because that's 2 O's stuck together. On the other side, I got, oh, look at this. 2 times 2, I got 4 H's. Hey, now it's balanced. I got the same number of H's here as here. What about O's? I only got 1. No, the 2 goes all the way through. It's like a multiplier. So, gang, I've got 4 H's and 2 O's. So look at now, I got 2 O's here and I got 2 O's there. This equation is now balanced. This equation is balanced. We're going to balance more equations. It's pretty mathematical, but and what do you got to do to balance them? Sometimes you got to guess and then check it and see if you're right. And if you're not right, you try it again. Okay? But well done. Thank you, group. So that's the symbol reaction for number 1. Let's do for number 2. All right, for number 2, we had oxygen gas. Okay, well, we know that, right? Because it's up here. So it's O2 gas plus wood. What's the formula for wood? Okay, wood is a bunch of stuff. Wood is many, 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 many different organic molecules put together. Okay, so we're just going to leave it as wood. Okay. Or if you want a fancy term that we'll study in 9th grade, you can call it a lot of hydrocarbons. Hydrocarbons. Wood is made of lots of stuff that has hydrogen and carbons in it together. Okay, then look at our products over here. Okay, so we got oxygen plus wood, O2 plus wood, forms water vapor and carbon dioxide. Give me the formulas, gang. So plus water vapor plus carbon dioxide. Let's see if somebody's got it there. So water vapor and carbon dioxide formulas would be what plus what? Thank you. Thank you, Tully and Lisa. Probably others are coming up with it too. Good. So H2O, probably a gas because we couldn't see it, and CO2, which we know is a gas. So a G there. Yeah, nice. Can we balance it? No, because we don't know what the formula for wood is. So we're done. We're done with the symbol reaction for the oxygen gas or burning splint test as well. Yeah? Cool. Good job. Questions from you before we switch gears to do something entirely new? Any questions for you? We're going to do one other chemical test, but I can't do it with you today because we're not at school. I'll do it maybe next week with you, next Tuesday, from the lab at school. Okay? All right, then I'm going to pause here and I'm going to race a little bit while you think if you got any questions. And we're going to start something new, kind of a whole new unit. All right, new month, new unit, right? Okay, here we go. Thank you for your participation, everybody. That is just peachy. Makes teaching in the basement a lot more fun when you participate, let me tell you that. All right, okay, here we go. We're going to start with a new idea which is called mole. It's one of the 3 parts of the curriculum for 8th grade physics. Okay, yeah, good. And what is a mole? Okay, a mole is not a maulwurf. Okay, well, it is, but only in biology, not in chemistry. A mole is a number used to count atoms or molecules. So it's a big number of atoms or molecules. That's what a mole is. Well, let's take another number we know to help us understand what this is about. Let's take a dozen. A dozen's how many, gang? Punch it in. What's dozen mean? Dutzend in German. Thank you, Marina. I'm sure everybody knows that as well. A dozen is 12 of something. Of whatever. Of people or eggs or a dozen countries or a dozen stars or whatever, right? Everybody's got that one. Thank you, everybody. So a dozen of something. All right, 1 mole is, you ready? 6.02 times 10 to the 23rd power atoms or molecules. Holy moly, so to speak. Now, you may not know much about powers. I don't know. Have you had powers like this in math class? Like 10 to the 23rd, something like that. Does that look familiar? It's called scientific notation. That is a big, big number. I agree. So that's the point. If you've had anything about this, yes, you've had some stuff about powers. Okay, not usually not that high. Thanks, UCN. Okay, I want to give you the real number just to blow your mind a little bit. All righty, I'm going to put it down below. Okay, so I got to kind of count a bit. So 6 and then whew. Okay, you ready? All right, so I put 6.02, then add like 21 more zeros. So now I'm going to go backwards and put some commas like we do in English. There's the thousands place. Here's the millions place. Here's the billions place. Here's the trillions place. Here's the I don't know what place, really high. Here's the even higher place. And here's the high. Oh, man, that's a big flipping number. So that 6 times 10 and 23rd is this amount of something. Now, we're only going to write that once because it's big. It would be silly to write that every time, right? We'd be here till like next Christmas or whatever. Yeah, so it's yeah, that's 21 zeros. So 602 and then 21 more zeros. And then that's that number, 6.02 times 10 to the 23rd molecules. This, by the way, is called scientific notation. It's got a front number between 1 and 10 times 10 to some power. You'll use it more in 9th and 10th grade. Okay? Yeah, Emily, it's a huge, large number. Okay, then comes my question, all right? Why? With an exclamation point, why did scientists pick such a big number? So we won't go into the 6.02 part, okay? But why do you suppose it needs to be such a big number? Let's see if you can guess. It needs to be a big number. Why? Or maybe think of it this way. Why can't it be a small number? Why couldn't I say, oh, how about 12 atoms of oxygen or 12 hydrogen atoms or 12 molecules of water or something like that? Why does it got to be a big number practically? It's for counting the atoms, yes, right? But still haven't answered the question, Marino. So yes, so why does it need to be a big number? That is a mole is a huge number of something. Okay, let's see if we got some ideas here now. Yeah, thank you, Coco. He says because atoms are really small, and there's so many. Okay, uh, and it's not just that there's so yeah. Okay, it's they're really small, so we need a lot to hold in our hand. So I'll give you an idea. If I had this, if I had this many moles of salt, it would fill my hand. I could measure out about that much salt. Okay. If I had this many moles of water, it would be just a little tiny bit of water here in my hand, about that much, not much, just a little bit of water. Okay. So atoms are really small, so we need a big number of them to be measurable, to measure them out on a scale, like to weigh them out. You know what I mean? Okay, so I can say, aha, we need many atoms or molecules to have enough to weigh on, now I'm going to say scale, but the actual scientific word for what we use to weigh stuff on is called a balance. That's a good word for you to know. So you're going to use someday, if we ever can do labs again, in person. I hope so. I hope I can show you a balance to weigh chemicals like, I don't know, whatever chemical, okay? So we need many atoms. That's the deal. To have enough to weigh. That's really the key of why a mole is such a big flipping number. Yeah, and a lot of you had similar comments. Thank you very much. Okay, I'm going to introduce you to the idea of mole now. How we doing on time? We doing okay? Yeah, we're doing okay. We're going to do more mole next time. But for starters, I hope you have it with you in your notebook. You need to have a periodic table. So I've got one at the back of a book. There's also one at the end of your planner, I think. So can everybody try and get a periodic table right now? So I got one here, but I can't hold that up so well for you. It's better if each of you has one to now and then next week as well. So find your periodic table, please. While you do that, I'm going to raise the board. Okay? Yeah. Okay. Okay. We can have what's called a molar mass. Now it sounds like something to do with your teeth, right? Your molars in the back of your mouth. No, no, it's the weight. So again, it has to do with weighing them out. The weight of 1 mole of whatever, atoms or molecules. And before we do that, again, just think about the mole for a second. Wouldn't it be great to have like a mole of chocolate chip cookies? Or a mole of euros, right? or maybe a mole of snowflakes. Well, actually, we probably do have that. There's a lot of snowflakes out there right now. So anyway, you could have a mole of anything, but in chemistry, we use it to count atoms and molecules. But I could have a mole of dollars if I go back to the US. That would be cool. I don't think there are that many, though. That's like more dollars than exist. You know what I mean? Okay, let's look at what we got again. Okay, so the weight of 1 mole of atoms or molecules. And here's the cool thing. You ready? So your periodic table, it has the molar mass of every element on it. The molar mass of each element is on our periodic table. Periodic table is like the coolest thing ever, isn't it? It's got everything. And let's do an example so you know what I'm talking about. Okay, so example. Give me a gas that if you breathe it in, it makes your voice really high and funny sounding. So if I breathe in this gas, it makes your voice sound really funny. What gas am I talking about? Hint, it's a noble gas. Oh, a lot of you knew that one. Good. Okay, Julius, Tully, and Brooks, and everybody, thank you very much. It's helium. So 1 mole of helium weighs, and now we're going to look it up together, and I'm going to show you where to find it, okay? All right, let me get my book. You get your periodic table ready. Go to helium, and it's the number right below. You see that? For me, it's 4.0, basically. Everybody find it? It's not the 2 up above. That's the number of protons. You know that already. The number down below is 4.00. We're going to just round them to the tens place. So we're going to say, hey, 1 mole of helium weighs, sorry, start again. Bad teacher. 1 mole of helium weighs 4.0 or 4.00 grams. Ta-da! So you can get the mole of anything, any element, either naturally made up through 92 or human made, the ones bigger than 92. So a mole of helium weighs this. Let's have you find a couple, can we? All right. So I'm going to have you choose. So I'm going to say your turn. Your turn. 1 mole of calcium weighs, and finally, 1 mole of, let's pick something big, uranium. Uranium, we're going to have that in 9th grade. Weighs, okay, so I know that you know this. Can you guys find them if you think you can? And I hope you know the symbols for calcium and uranium. Look and find them on your periodic table. Find me both of those numbers. How many grams? And throw the label grams on it too. So a mole of calcium is grams. Mole of uranium is grams. When you find them, type them in, please. And let me know which one is which. I just want to see that you can find this on your periodic table, okay? If everybody can, we're doing good. Waiting for your answer now. I got my blue marker ready. And are we still recording? Yes, we are. So the molar mass of calcium and the molar mass of uranium. Find it on your periodic table. UCN has one. Good. Okay, UCN has CA. Oh, so does Stephanie and Tully and Tilly actually has it as well. So it's 40.08. Now, we're going to go to the tens place. So I'm going to say, we're going to round it to 40.1. G for grams. Yeah. Okay, somebody else find uranium. Thank you, everybody. Can you find uranium and find its molar mass? Hint, it's heavy. So that would be like what? That you could hold in your hand, right? That's not a lot, 40 grams. 40 grams. Okay, uranium. How much does that sucker weigh? Find its molar mass. It is heavy. And you better believe it. Hint, hint, hint. You, the symbol. We got it. Thank you. Stephanie has it. Let's see some others come up with it. It's way down at the bottom of your periodic table. See if you can find it. Yeah, now we got a couple others. Usian and Tully have it as well. So it's 238. And we're going to go and show the tens place is also a 0, so 0.0 grams. All right, that's a quarter of a kilo. So that's like a pretty good chunk of stuff, all right? A quarter of a kilo of uranium. But you wouldn't want to hold it in your hand, by the way, because it's radioactive. Okay. But if you could see it, it would weigh about a quarter of a kilo. Yeah. So, but it makes sense, right? Because helium atoms are really small. So if I have a mole's worth of helium atoms, right, it weighs that. Calcium atoms are bigger. So if I got the same number of them, it weighs more. And finally, uranium atoms are huge. And if I got a mole of them, it really weighs a lot. So I hope molar mass is understandable to you. Mick, we're about done, so you're going to have to watch the video. But you can do that and still make the notes, Mick, and then send me a copy of your notes. And then I'll give you points, okay? All right. Good. Let's do this. Folks, I'm going to give you a homework assignment, and I want you to know how to do it. So let's talk about what your homework's going to be. I won't give it to you now, but I'm going to show you how to do one. Okay, so find the molar mass of compounds. So molar mass. So example, the molar mass of table salt. Table salt, remember the formula? NaCl. Well, look at it. It's got two elements in it. So guess what we got to do? We got to add them up. So the molar mass of table salt is, well, we got to get the mass of Na plus the mass of Cl, and we'll get the whole thing. Okay, somebody find me Na and type it in, and somebody find me the molar mass of Cl and type it in, please. And then we'll add them up, okay? We got just enough time. So I want the molar mass of Na and Cl, and then we're going to put them together, okay? Thank you, Lisa. So that's 22.99. We're going to run it to the 10th place and call it 23.0 grams. Somebody else, Cl. Cl, can somebody punch in chlorine? Thank you. I got from Stephanie, Tully, and others. I got that. And then from Brooks, I got Cl 35. Let's round to 35.5. Why are we rounding? Because eventually you'll need to round, and we'll talk about that in 10th, 11th, and 12th grade. So you might as well learn now. So just round them to the 10th place, all of them. Okay, let's add them up. So if I got each of those in there, if I got a mole of those and a mole of those, then I got this bigger weight together, don't I? So it's what, 50? Can you do the rest of that? So what would be the molar mass of NaCl? Just so I know you're following and you know what I'm doing. 50 We got just enough time if somebody punches in. There we go. Thank you, yo. 58.5. Here's how we write the answer. It's grams per mole. Ta-da! So the molar mass of NaCl is that right there. Your homework is going to be to find some molar masses. You're going to have to add them up and do just what we did together. And yeah, type them in. So I'll give you that. We won't meet again this week. Instead, I'll give you an assignment to do that. Shouldn't take you that long, but I want you to do some with your periodic table. And then we'll meet again next Tuesday, all right? You guys were super. Thanks for participating, and we'll see you next week. Have a good, safe week and a good first week back to school, everybody. Bye-bye.